Hi class, it's Bill Berry here, back with a continuation of week 1, mostly review concepts for those of you who are taking Java 2, and we are covering a few of the things that if you didn't see in the previous course, you will need them for upcoming projects. So today we're talking specifically about multidimensional arrays. Going to cover those quickly. Hopefully you did see those before, but let's just review a couple of the key things that you need to know about those. First, when you're working with a multidimensional array, remember that in Java, these are arrays of arrays. So if you're thinking of a 2D array as a table, just remember that while that might be a useful conceptual model, it's not actually how things work, right? Everything is an array of arrays when it comes to Java. So, if you want to think of it that way, great. But just remember that the concept of row and column doesn't really apply. That's not how it works here. I'd much rather you get used to the conceptual idea of the first dimension means something specific contextually, the second dimension is tracking something else contextually, and if you can follow that, you'll actually be in better shape, and by the way, you'll come up with better variable names. We'll talk about that. So we'll look at how they're declared and how they're accessed. The length property certainly is of interest here because we have 2 dimensions, and etc. Let's see, anything else? Let's just move on. All right, so let's say that we wanted to make a seating chart for a class, and assuming that there are 4 rows of seats and each row has 7 seats. Now notice we are making the assumption here that we are having arrays that are very even. So let me get a pen. Notice that every single row has 7 seats. There might be scenarios where you don't want that to be the case, where rows have different numbers of seats. We'll handle that in a different video when we talk about jagged arrays, which are certainly supported in Java. So, but for each seat we want to record the student's name, right? So that gives us the idea that at the core we're going to be storing strings, right? So first let's figure out, as we usually want to, okay, let's diagram this. How would we represent a 2-dimensional array in an object diagram? Well, remember that they are arrays of arrays. So we might have a seating chart variable in main or something like that, and each of those is then going to point to one of the rows. Right? We're thinking of the rows as the major thing. It doesn't really matter whether you want to think of, which thing goes first. You just need to make sure that you are consistent in your thinking. In our thinking in a particular classroom, probably rows make sense. So this first dimension is going to represent the fact that we have 4 rows marked 0 through 3, of course. Now each of those rows, and notice the data type here. The data type here is a string array of arrays, or if we were trying to be a real purist in UML, we might say array of arrays of strings. Right? It's an array of arrays of strings. But the data type here is the 2 dimensions, but each one of these then points to an array of strings. So note the data types, and then each one of the elements within that is going to be a single string. So array of arrays, array, string. So if we're going to draw this as an object diagram, this is how we do it, and of course arrays just have indexes. They don't have names here, so to show that we can do this. Notice also, while I'm not sure this is UML convention, at some point when you're trying to illustrate this, you don't necessarily want to fill in every single one. So what I do is sometimes put dot dot dots, or sometimes just say yeah blah blah blah. You get the picture, you understand. So we don't have to put in umpteen, right? We don't have to really fill in 28 of these when we do our diagramming to show the point that we're trying to make. So again, this underscores the fact that 2-dimensional arrays are arrays of arrays. Also remember, you can certainly have more dimensions, and if so, this one's going to be array of arrays. This one's going to be an array of arrays, the third level is going to be an array, and then each of those is going to be a string. So you can certainly have as many dimensions as you want. You just have to get it straight, right? Which thing each dimension means, and very clearly for us, this is the rows in the classroom, and this one's going to be the seats. And these are the individual seats within this particular row. So that's how we'd show them in an object diagram. Next, what does the code look like? Well, first, again, I'm going to get really clear and make sure that all my variable names are very in sync with this, because I'm going to say, hey, look, the rows are the most important thing and the seats are next. So you'll notice when I declare right from the beginning, I'm using the concept of row and the concept of seats, and I'm going to make sure that when I loop through this later, I'm very clear, because if you get these backwards, right, if you get these backwards at any point, you're going to go beyond the edges of the array. That also means, I'll put a little asterisk here in bad drawing, that you need to test for this, because it's such a common mistake that when you go to test your code, make sure that you test arrays of different shapes. So in this one I have a 4 by 7, but you should probably have an example where you have a 7 by 4, right? Make one very skinny and one very fat so that you can find those places where you've mixed up the variables, because something's going to blow up if you do that. So testing is important here. So notice here, again, when I declare this, this is going to be an array of arrays, and then I have to give the 2 dimensions at some point here, right? You've got to fill it in. And then each one of them, notice, when you have a 2-dimensional array, all of the indexes are going to typically, when you want to find an individual string, you've got to say which row and which seat does Yuriko sit in. All right, so in this case, I'm assigning Yuriko to this one, Miguel, Alan, etc. Now, when you go to print these out, remember that Java will generally print the address of something that is that is a reference type, right? So if you just try to print it, right, if you just try to print the seating chart, you're just going to get out the address. All right, that's not going to be very helpful. And even if you use arrays toString, what you're going to see is you're going to get a bunch of addresses, right? Because it's going to be the address of each subarray. But if you use this thing called deep toString from the arrays class, that's a nice static method, and that says dig in, keep digging in, right? Get all the way down. So if you do a deep toString, you'll actually get these things printed out as arrays with the brackets and the commas, and that's not a bad way to go. All right, so that's just a little bit about how you set up a 2-dimensional array. Again, you're going to need that for your upcoming project, so you might as well kind of get used to that. So now, how do we loop through them? Let's see how we loop through these. There's a couple of different good ways. Remember, these are arrays, not array lists, so how would we do that? Well, one traditional way to do that is to use a standard for loop, where you're using indexing. Now, the variables, notice I'm being very careful. Again, I've used the word row. I actually might be more likely to say row index, like row IDX, so that I'm very clear that the loop variable is intended as an index through the rows in my 2-dimensional array. So row or row index is a great variable name. I is a terrible variable name because it doesn't really give you the contextual knowledge and you might get them mixed up. Same thing here. This is seat or seat index. So here I'm very clear. I'm looping through the rows, and for each seat I'm doing a particular thing. So I highly recommend you use better variable names here, and yes, I will complain about this in your projects if I see you misusing them and doing I's and J's, because that's a bad habit to get into, especially when you get into 2-dimensional arrays. Notice also how I can use the length of the array. In this case, the rows are dictated by seating chart.length, because remember, right, this is the length of this array, and that's the number of rows. So seating chart.length is going to be 4 in this case, right? But if I want to find the length of any particular array, notice in this case I'm doing seating chart bracket 0.length. That's going to be the length of this array, right? So, and since they're all the same length, I can just use a 0 here, right? I don't have to get the particular one in question. I could use row here, right? But that certainly gets out the length. So in this case, notice I don't have to keep a separate variable for the lengths, even though I know that in my code I have row count and seats per count. I don't really need to depend on those, because as you'll see later, we can do jagged arrays and these can be different. So I like using the length of the array and not counting on anything else in case you change them dynamically at runtime. Now there is another way to loop through this. If you haven't seen a for each loop, a for each loop is pretty cool, right? And I've already mentioned this, I and J, bad ideas when it comes to 2-dimensional arrays. I don't like them anyway, but certainly with 2-dimensional arrays, don't do it. Okay, so what does a for each loop look like? Well, first of all, it uses a colon to separate the collection on the right from the element in the collection on the left. Notice this one's a little hard to wrap your mind around at first, but if you think of it this way, always write this part first, right? Put the colon, then over here write the name of the collection. Obviously we're looping through the seating chart, right? And then, let's go back a couple slides. Conceptually, what is each element in the seating chart? What is the data type of each element in the seating chart? And this object diagram makes it really clear. If seating chart is referring to this, each element in this is actually a string array. Does that make sense? Seating chart is a string array of arrays. Each element in it is a string array. So therefore, when we go to write this out in a for loop, for each loop, notice that this now is the array of arrays, but this is going to be an array, right? Each element's going to have one fewer set of brackets, and we give it a name. In this case, each of those things represents a whole row, right? And then within that, now we can now dig into the whole row in the inner loop, right? A nested loop, since it's 2 dimensions. Now we take the whole row, and what is the data type of one item in each element in that row? Oh, it's a string, right? It represents one seat or one person. So in this case, we've got to pay attention to these, but once you get used to the nomenclature, that's actually darn good, right? That's actually a pretty clean loop. And remember, one by one, it's going to feed you these things in this loop, so you have now one seat in your hand, and inside the inner loop, you can use one seat however you want to do it. Remember that for each loops are great when all you need to do is visit, right? When you need to go do some algorithms that need to add things up or print things or check things. It's not so good if you need to make changes to the meta set of the array itself. Notice here you don't actually have access to the indexes, so changing what each thing points at is not going to be useful, whereas here you have the indexes, so you could actually kind of remap everything, right? From using an index, you can point to a whole new string, you can point to a whole new something, right? Whereas here it's a little more limited. So for visiting, for consuming data, a for each loop is great. For changing the level above, right, for actually remapping the array itself, you probably don't want a for each loop. You're going to find that a for loop is going to be more powerful in that sense. But I like them. It's very concise, and I like the terminology here. All right, so again, here's just a little more hint about it, where you put the element first, data type of the element, and then the actual collection that you're trying to look into. All right, now if you want something a little more realistic, I'm just pointing out something that you might have. And let's say that I have weather data for a whole year in a file, and I want to put it in an array. Maybe I think of putting it in a 2D array organized by months and days. If so, I have all this data. Maybe I organize like this, right? In this case, the first dimension is going to be the month. Usually we think of that as the most important one, so we put it first, and the second dimension is going to be a day. So each of these is going to be an array of weather days. That's going to represent the whole month of January. And then each of these is going to be a weather day object, which is going to hold all of that data. So this is an example of, rather than putting strings in, we're actually putting an object reference. Now let's go back a couple slides. Remember that we're actually cheating here, because strings are not primitives, but we're kind of cheating by making them look like primitives here. I do this because if you don't, your object diagrams are going to get really crazy and really big. So for strings only, I sort of make an exception and say I'm just going to pretend they're primitives for this purpose so that my diagrams don't go crazy. So really, if we were really doing a string, it would still have to have another box. But in this case, this is a more clear example where we have another data type. We have a weather day object, and each one of these refers to those. So this is kind of a fun way to think of it, and my students did a project kind of like this, except we did it in a one-dimensional array rather than a two. But if you wanted to see that, you can ask somebody in the class who was in my 142 class, and they can show you what we did here. It's a little easier to put it in one array if you're doing things that cross month boundaries, but certainly if you're really focusing month to month, this could work very well. Notice the other thing, again, this is a little teaser for an upcoming lesson. Notice that here, since it's a regular array or rectangular array, all of these months have to have 31 days. and then we have to figure out what the heck do we put in here, right? What do we put in here? That's fine for January, but what about this one, right? What do we do for February? So we'd have to put nulls in or find some other way to sort of suppress that, because we know we don't really want to use those days. We're going to see with using jagged arrays that not every month has to be the same length, which is perfect. So keep your eyes open for that coming soon, but that's the general concept of a two-dimensional array. Again, hopefully it's review, but just wanted to make sure we went over that again so that you're ready for an upcoming project, because you're going to certainly be using 2D arrays in the very first project. So thanks for watching this video. Stay tuned. We're going to keep working on some other concepts. The next video we'll talk about enumerated types, and then we'll go perhaps into some little more esoteric stuff, like how can you dig a little deeper, how can you ask the compiler to check a little deeper for you using excellent, and debugging may be also a concept that I make a video on. So thanks for watching this one, and hope to see you in a future video.